right? I'm not sure if you guys saw, but what I did yesterday is I recorded the session like I told you, and I actually went ahead and uploaded it to the announcement from yesterday. So if you look here, now there's a YouTube link that goes to that recorded Zoom session for yesterday, right? So if something didn't make sense, you wanted to, or you just happened to miss, you know, the session, you came to class late, you missed it in its entirety, you can watch that session, right? It's long, it's 45 minutes, I didn't edit it, but you can skip around if you have some questions there. Okay, I'm gonna try to do that every day. Just somebody please remind me if I forget to set the record button to record it, all right? So just remember, we're talking about ratios, and the idea is to kind of familiarize ourselves with the ratios a little bit more and work on converting between different types of ratios, right? So if you got pretty far through the activities yesterday, you should have started to see some of that practice, all right? We watched this video, I'm just gonna skip through that. Did anybody have any questions on this page here, where you were comparing the different ratios for the different parts of the fruit salad? All right, if there's no questions, I see a no, thank you, Anthony. All right, also, are you guys aware of how to use the buttons for like yes, no, go slower, go faster, more? If you click on participants, you should see a list of everybody's names, and you should see some buttons where you can hit like yes, you can hit no. That's just another way to give me nonverbal feedback, all right? Because right now I have the participants panel open, I have the chat window open, so sometimes I have to close the chat window just so I can see more stuff on my screen, and that's just another quick way to let me know, right? There's also an option to raise your hand if you have a question, and then I'll see that and I can tell you, okay, I have a question, right? Thank you, Alex. I see that you hit that yes button. Okay, so I'm gonna skip to the next part because it doesn't seem like we have any questions there yet, right? So main thing that we talked about yesterday is that, remember, the order of the quantities in the ratio is a big part, right? Like if we said something was, in this example here, this is 1 part cherry, 1 part apple, that's not equal to 2 parts apples and 1 part cherry, right? That just makes sense looking at that. But thinking about numbers, give me a second, right? When we talk about ratios, we say that the order matters. So if I said that the ratio to 5, right? That's not the same as a ratio of 5 to 2, right? Those two things are not the same because the numbers are in different spots. So this would be like saying I had 2 cherries to 5 apples. That's not the same as 5 apples to 2 cherries, right? Let's see. Okay, so the next thing, expressing ratios. In math, there's a lot of different ways that you express ratios. So you can express them with a colon, you can express them with the word to, or you can also express them as a fraction. Again, anybody, just please let me know if I'm going too fast. So numbers, right? If this was like, say, maybe I could say 5 apples. The way that I read that colon is 2. So 5 to, let's say, 3 cherries. That's a ratio. Or you can use it with the word to. So you could say, you know, 5 strawberries to 3 cherries. That's another way to write a ratio, right? A third way to write a ratio is using a fraction, right? So again, I could say maybe 5 cherries to maybe 3. That's still another example of a ratio. When we start getting into like high-level math classes, 7th grade, 8th grade, algebra, we're pretty much going to use fractions anytime we're talking about ratios, because mathematically it's easier to work with a fraction, right? But all 3 are different valid ways of using ratios. Again, let me know if you have any questions as I'm going along. So this example over here, it says when making 2 fruit salads, Priscilla and Jack must use twice the quantity of each variety of fruit mentioned in the recipe. So remember that recipe for the fruit salad is over here on the left-hand side, right? But she wants to make double the recipe because they're expecting more people to come. So it originally called for 1 part. Remember, what was a part? Does anybody remember? If I'm talking about a part of apples, what did a part of apples mean yesterday? That a tablespoon of apples? Is that a slice of apples? Is that, I see Alexander has your hand raised. Can you answer that for us, Alex?
A cup.
A cup, good, right? So it's important when you're reading through these word problems to have context. If you're saying, I don't know what a part of an orange means, it's just gonna make it a little bit more confusing for you. So remember, we were talking about diced up fruit. So 1 part is equivalent to just 1 cup. That's diced up, right? So the recipe called for 1 part of apple, which is a cup of apples, a cup of oranges, 2 cups of cherries, 3 cups of grapes, and so on. Now, if she wants to double the recipe, basically all you have to do is just double the individual parts, right? So we doubled the apples, so now we have 2 cups of apples. We doubled the cherries, now we have 4 cups of cherries. We doubled the strawberries, now we have 8 cups of strawberries. So that's how doubling a recipe works, that's how doubling a ratio works. You have to double all of the components of the ratio, right? If we only doubled, say, the strawberries and the grapes, but we left everything else the same, it wouldn't be the same fruit value, right? You're adding a lot more grapes, a lot more strawberries, and everything else, right? And what you're also going to see here, guys, if your background is loud, just please mute yourself when you come in, unless you have a question that you want to ask at the time, okay? So the second thing that happens when you double that ratio is that everything gets doubled, so you actually end up with more total parts in the end, right? So the entire ratio, it gave us 11 cups of fruit altogether, right? Versus the doubled version gives you 22 parts of fruit. So when you double all the parts, in the end, you're obviously going to double the product that you end up with. Again, if I'm not hearing people asking to stop for questions, I'm going to keep on going, okay? So next thing is you have different types of ratios, right? And this is where you want to be careful with wording, right? Because wording can really mess you up with ratios if you're not careful. It's really easy to make some mistakes, all right? 1 second, I'm just checking the chat. All right. So first type is a part-to-part ratio. So when you're talking about part-to-part ratios, you're just comparing the different parts of the ratio, if that makes sense, right? So let's say I was talking about this fruit salad here. I could say that I have, 1 part of apple to 3 parts grape. I'm just comparing the different parts with each other. I could say I have 4 parts of strawberry to 2 parts cherry. So anytime I add 4 strawberries, 4 cups of strawberries, I also need to add 2 cups of cherries, right? That's what a part-to-part ratio looks like. So examples it says over here, it says, in Jack's class, there are 8 girls and 7 boys, right? So let's say there are 8 girls to 7 boys. That's how I would write a part-to-part ratio, just comparing the number of, in this case, girls, my pen is a little bit lagging, to the number of boys being 7, right? That's a part-to-part ratio. I could also flip the order, and I could say I have 7 boys to 8 girls, right? They just represent different parts of the ratio, right? That's different from a part-to-whole ratio, right? Which we're going to see on the next slide. In a part-to-whole ratio, you're comparing 1 part to the total number of things. So in this case here, it says that we have 8. Is that girls or boys? 8 girls, right? It says that we have 7 boys. So a part-to-part ratio says 8 girls to 7 boys. If we want to talk about a part-to-whole ratio, what a part to whole ratio would look like is it would say, how many boys do you have to the total number of students? So how many boys do we have?
7.
7. So I have 7 boys to how many students do I have altogether?
15.
Including girls and boys is 15, right? So this is where you want to be careful, especially when it comes to the mastery test, with the wording. Because it's easy if you're not being careful, you're trying to go quickly, you think you know it, to just make a mistake and miss that it actually said something like students instead of saying something like boys, right? So that's going to explain that a little bit more in the next slide as well. But hopefully that clarified some things a little bit, because I saw a couple of people who got some of those parts of whole questions wrong in the mastery test. Right? So next one is whole to part. So just like I said before, right? Maybe not right now. It says in the fruit salad recipe, Patricia and Jack used a total of 11 parts of fruit, right? Right. Daddy's teaching. Okay. Not right now. Sorry. A whole to part ratio compares the total quantity to one of the parts that adds up to the total, right? So if we're going back to that fruit salad recipe, we know that it had 1 part of apples, right? So thinking again, back to the fruit salad. Remember that recipe, it had a bunch of fruit in it. I could say that it was 1 part or 1 cup of apples to all together, there's 11 cups of fruit in the end. So 1 cup of apples to 11 cups of fruit. This here would be an example of a whole to part or part to whole ratio, right? When you're comparing one of the parts to the total number of things that you have together at the end. And I believe there's
whole to part ratio.
Sorry. Right, and then there's part to whole, which is basically the same thing, but you just have it reversed, right? Part to whole to part are really just the same thing. It's just the order that they ask you for it. Right? So hopefully, oops. Sorry, I've got a lot of tabs open here. All right. So ideally, you guys already did this yesterday, right? I'm just kind of reviewing some stuff, going over some things. It says Jim has 3 cats, 5 dogs, and 2 rabbits. Make each type of ratio to the correct description of Jim's pets. So if I'm talking about 5 dogs to 10 pets, is that part to part, whole to part, or part to whole? Can somebody help us out with that?
Part to whole.
Okay, how do you know it's part to whole?
Because it's 5 part dogs to 10 pets. So
good. Right? So the parts are the individual animals. Dogs and cats are the parts. The whole in this case is grouping them all together. So that's saying the number of pets that you have is going to be the whole, right? And figuring out whether it's whole to part or part to whole just depends on the order. So you read it left to right, just like you do with English, right? So if the whole comes on the left, that's whole to part. If the whole comes on the right, that's part to whole, right? So if you didn't do this activity already, make sure that you do that. Right? The next thing that it goes on to doing is talking about ratios in simplest form, right? So sometimes you have a ratio and you can reduce it, right? If you're good with fractions, I find that a lot of students have difficulty with fractions, and if you're one of those, don't worry about it, right? This goes on for a long time, right? I've had students in high school that still struggle with fractions, right? So you're going to be working with fractions for the next couple of years, and just hopefully as time goes on, you get a little bit better with them and you're just not as intimidated by them, right? So for example, let's say we're looking at this ratio over here that says 12 to 16, all right? Remember, you can also write it as a fraction as 12 over 16. Okay, Noah. Sorry, I was just reading the chat. All right, so It says sometimes you come across a ratio that involves large numbers. You can simplify such ratios without changing the value, all right? So this is really like when you learned about equivalent fractions. So just to give you a really basic example, right? I might say something like the fraction 2/4 is equal to, does anybody know a simpler way that I could write this fraction?
Me. I have no idea.
So 2 is
1/2.
half of 4. A simpler way
1/2.
to write that is 1/2, right? So when we talk about simplifying ratios, it's really just about simplifying fractions, right? And another way to think about why these two are the same, right, is, for example, let's think about fruit, right? Let's say what this meant was, let's say it's 2 cups of apples to 4 cups of, say, oranges. And my pen is not cooperating today. So 2 cups of apples to 4 cups of oranges. If I'm saying that these two are equivalent, that means that I could make the same recipe using smaller quantities. So I could actually make the same thing. It would taste the same using 1 cup of apples and 2 cups of oranges, right? They're going to end up being equivalent quantities, because if I were to double this one, I'm going to end up getting 2 to 4. Right? Give me a second. I'm just checking the chat. Okay, good. I see that some people got that 1/2 right. All right. Now, it's giving you some ideas here on how you can go ahead and simplify these when they have bigger numbers, right? So looking at the example of 12/16, it says the first thing that you want to do is write out the top and the bottom. It says as a product of factors. Does anybody know what that means, product of factors? Right? Product in math just means multiplication. Factors just mean things that you multiply together. So if I take 2 times 2 times 3, 2 times 2 is 4. 4 times 3 is 12. 4 times 3 gets me to 12. Over here, 2 times 2 is 4. Times another 2 is 8. Times another 2 is 16. So you write them out with all of this. Right here is actually a prime factorization, which you guys should have done in 6th grade. Depending on how you're working, you don't always have to do a prime factorization, right? Another way that I could have done this here is I could have said, okay, I know that 12 is 3 times 4. I know that 16 is 4 times 4, right? Now it says identify the common factor. Common just means the same, and the numerator and the denominator. So in both of these on the top and the bottom, I have a 4, right? So what you can do with fractions is if you have the same number being multiplied on the top and on the bottom, is I can get rid of a 4 from here, I can get rid of a 4 from here. So in essence, I'm left with just this chunk here, this 3/4. Right? Please let me know if you have any questions here, right? So I know that this here is equivalent to this, and it's basically the same ratio, except all I did is I multiplied this ratio by 4. So once you find this common factor, that's kind of telling you how big you scaled it up by. So think about this here as like your fruit salad recipe. It called for 3 cups of apples and 4 cups of oranges, right? What we did though is we quadrupled it, so now you have 12 cups of apples and 16 cups of oranges, right? So when you're doing this, you're basically working backwards to try to figure out what the recipe was. That's another way that you can think about simplifying these fractions. Okay, so this one over here says, what's the simplest form of the ratio 32/48, right? I want to help do this one with you guys in case you have any questions. And hopefully somebody can help me out with this, all right? So 32/48, what I typically like to do is I like to write these as fractions first. So I would say, okay, that's the fraction 32 over 48. So does anybody know what's the first thing that we should do here? If we think back to what I said on that last page. All right, so the first thing I want to do is I want to express this here using the factors. So thinking about it, what numbers can I multiply together to get 32? Can anybody just tell me two different numbers that I can multiply to get 32? All right, so one thing that you can always do, these two numbers are both even. So worst case, you work with the 2. So 2 multiplied by what gets me to 32? 16. Thank you, Logan. So 2 times 16, whoops, gets me 32. What about the bottom? What times what can get me to 48? And again, it's even, so let's try 2. 2 times what gets you 48? 24. Okay, good. Thank you. So 2 times 24, right? I have a common factor of 2. So I'm going to cross the 2's out. Now I'm left with 16 over 24. But I'm not done yet because this isn't simplest form, right? And let me just check. Whoops. Sorry, I've got a lot of tabs open right now. Nope.
What did you say?
I was just checking something. Okay, so sometimes you have to be careful. It might give you this as an answer choice. So it might give you 16 over 24 as an answer, but that's not simplest form, right? We're lucky because it didn't do that to us here. Next thing I'd want to do is, okay, now let me factor this again. So what times what gives me 16? Okay, 2 times 8. All right, I see Alice giving us the final answer. Let's see, Alice at 2 over 3. Let's see if that's what we get. So we say, and if you can do this faster, don't worry about it. I'm just showing you guys a way that is always going to work, okay? So 2 times 8 gets me to 16. How can I get 24? What times what? Okay, 2 times 12, good. I cross out the 2's. I've got 8 over 12, right? Again, they're both still even, so I can again do this one more time. I can keep going until I get like an even and an odd number, and then you'd have to check to see if there's any other common factors. So 2 times 4, I'll just help you out here, gives you 8, not yet, Loki. 2 times 6, so I'm down to 4 over 6, and again, they're both even. So my last step would be 2 times 2, and 2 times 3, right? So final answer is going to end up being 2 over 3. Now, you want to be careful when you pick your answer, right? 2 over 3 is not the same as 3 over 2. So the correct answer would be the top one, and good. Alice was correct. Good job. 2 over 3. Now, this took a long time, right? It's going to work, though. So worst case, you can't figure out what factors. Do this long method, work with the even numbers first. 2 times what gives you the number, cross out the 2's. That should get you your final answer, right? But once you get a little bit better, you can start to factor things a little bit faster, right? I can look here and I can say, okay, I pulled a lot of 2's out of there. So maybe instead, I could have started with pulling out, like, say, an 8. If I remembered that, 8 times 4 gives me 32. I know 8 times 6 gives me 48. I cross out the 8's and I have 4 over 6. Now I just need to factor out another 2 to still get down to the 2 over 3, all right? But whatever you do, however you see it, try to figure out what works for you. If this long approach works, if you want to use a larger factor, right? Also, if you saw it, which a lot of people might not have, you can say 16 times 2 and 16 times 3, right? That's the fastest way to factor it. 16 times 2 gets you to 32. 16 times 3 gets you to 48. So now I'm left with that 2 over 3, right? But unless you know your multiples of 16, that might have been hard to see right out the gate, all right? But again, this long approach always works. You don't always have to factor out a 2. You can try factoring out a 4, something that's a little bit bigger first. But the idea is to get the same on the top and the bottom. All right, guys, I'm gonna ask you to just keep the chat focused on the math that we're working on so I don't have to shut off the chat and leave it on post only. All right, any questions here before we move on? Because I know the mastery test has a couple of these here where it's asking you to simplify these ratios. So just make sure that you try to use this approach, you take your time with it, right? You have unlimited time for those mastery tests. It's not time, so there's no reason to try to rush through it and just pick an answer, right? I'd rather you spend an hour on it and get it right than kind of rush through it in 10 minutes. Okay, so next page, let's just look at this one here. Okay, so it's talking about comparing ratios. So trying to figure out if ratios are the same or not. You basically want to see if you can scale one up to the other. So we'll look at the example. What do we got over here? Okay, so what it's talking about now is trying to figure out whether or not ratios are equivalent, right? So let's look at the examples that they give us here. All right, that's, okay, let's look over here, right? It says match each ratio to an equal ratio. So we need to try to figure out which of these over here are equivalent to which ratios over here, right? I'm not going to do all of these for you together. So you still have some time to practice, okay? Okay, good, Alex. Now, these examples here, right? Let's say I want to look at the ratio 1 to 4. I want to figure out 1 to 4. Is it equivalent to any of these ratios over here? So the way that you do this is by scaling it up. So let's start with this one first, right? 1 to 4. Okay, good. People, right, you should have done it yesterday. I'm just kind of going over it today to make sure that you can follow along, that you guys understand it, all right? If you, all right, let's see, it's actually 9:14. So if you finished all of this so far, yesterday, you understand it, go on, you can work on the mastery test. That's what we're doing for today, right? If you already finished the mastery test, you're already at an 80 for it, then you're good for today. Tomorrow we're starting out with the next lesson. But if you still have any questions at all, you're having trouble with the mastery test, you definitely want to stick around for the rest of the class, okay?
I'm having trouble.
Okay, good. Right, so at this point, if you know what you're doing, you don't need any further guidance, you're good on the mastery test, you can leave the Zoom session, but otherwise, you definitely want to stick around and get some assistance, okay? So I'm going to go over this example here, right? Let's say I'm talking about 1 to 4. Let's say, is this the same as the ratio 4 to 48? So I'm going to show you a really easy way to do this, right? Basically, what I'm trying to do is I'm trying to get this 1 to 4 to equal the ratio 4 to 48. When we think about scaling up these recipes or these ratios, you multiply. So to get from 1 to 4, what do I have to multiply by? Right? I multiply by 4. Now, remember, if I multiplied one part of my recipe by 4, I need to multiply the other part. So I just need to check. If I was to multiply 4 times 4, is that going to give me 48? No, right? 4 times 4 is 16. So 1 to 4 can't be this one. And you just do it one by one. Same thing for 1 to 3 can I sorry, for this one, 1 to 4 to 4 to 6. Can I take the ratio 1 to 4 and get the ratio 4 to 6? No, because again, I'm going to have to multiply this guy by 4. And if I multiply 4 times 4, I do not get 6. So it's not this one. It actually ends up being this one, right? The live session, Priscilla, ends at 9:30. It's this one here, because if I were to take the ratio 1 to 4, compare it with the ratio 2 to 8, right? To get from 1 to 2, I'm multiplying by 2. To get from 4 to 8, again, I multiply by 2. So that one works out, right? So that's the process that you're gonna take when you're trying to figure it out. You just basically look for the smaller number, multiply it, multiply the other one by the same number. If it works out, it's correct. If not, that means you need to try something else, okay? Again, just please take your time with these. There's no reason to rush through this stuff. If you have questions, again, please let me know so I can try to re-explain it, right? The mastery test has a couple where you're scaling these ratios up, right? I believe that's pretty much it. There's one last slide. That's just the summary. So let's read through the summary. Then I'll stick around in case people have questions about this content here. And you're gonna have the rest of the independent practice time to just finish any of this up, look over it, work through the mastery test. So it says, using the ratios in their grandmother's recipe, Priscilla and Jack figured out the quantities of the different fruits they needed to make 2 fruit salads. A ratio is a way of writing a comparison between 2 quantities that tells you how much bigger one quantity is than the other. You can write a ratio as 2 numbers with a colon between them, as 2 numbers with the word to 2 between them, or as a fraction. Yeah, so the idea, Errol, is to finish the mastery test by today. The lesson introduced these concepts, right? So a couple of quick things. It says, if we change the order, we get a different ratio. So the ratio 2 to 3 is not the same as the ratio 3 to 2. Not yet, Penelope, I'll let you know when, almost, right? This ratio is not the same as this ratio. Also, if we multiply or divide one quantity in a ratio by a number, we need to multiply or divide the other quantity by the same number. So if I had the ratio, say, 2 to 3, and I wanted to double it, I have to double both the 2 and the 3. So I would end up with the ratio 4 to 6. Next, it says to simplify a ratio, we factor the quantities in the ratio and cancel the common factors. So thinking about this ratio here, right? Let's say I had the ratio 4 to 6. The way we did that is we said that that's like saying 2 times 2 divided by 2 times 3. You'd cancel out the 2, so you're left with 2 over 3, right? That's basically just like simplifying fractions. The last one is you have 3 types, right? Mainly 2 types. Most of the time in math, we're gonna end up using part to whole ratios. We really rarely use whole to part ratios when you get to higher level math classes, right? It's almost always gonna be a part to whole or a part to part, right? Just realize that whole to part is just a part to whole in reverse. So for example, if we had this ratio part to part, we were talking about, 2 parts of fruit, 2 parts cherries to 3 parts strawberries. A part to whole, you'd have 2 different parts of whole. So you could have one that's 2 parts, say strawberries, to 5 parts of fruit, or with the other part, you could say 3 parts of, I forget what it was, cherries, to 5 parts of fruit altogether. So you're just taking the part, comparing it with the whole, right? So that's pretty much the whole lesson for today, right? Again, ideally the way that this works is you should have worked on this already yesterday when you have some independent practice time. And then today, the next day, I'm gonna go ahead and just review some of that stuff there, clear up any questions that you guys have about it, right? If you do it like that, you're going to get a whole lot more out of this class than if you wait until the second day when I go over stuff. Because I'm not always going to answer all the questions like I did today, so you're still going to have to finish that stuff. Okay? So basically for the rest of today, we've got 9 minutes in the live session left. If you don't have any questions, you can head out. If you still have some questions, please stick around. Let me know. I can go back a couple of slides, re-explain something, and then you guys are going to be working on that mastery test. All right?
Hi, how are you?
I'm good. How are you doing?
Okay. I have a question about the ELA. I don't see the Zoom link for ELA class.
I believe she said that she was going to put it on the iLearn homepage. Do you get to the iLearn homepage for ELA?
Yes, I see your homepage, and then I went to the 9 small boxes and see her homepage.
Uh-huh.
I don't see any Zoom link.
You don't see like an announcement posted somewhere?
I see the announcements. I see a lot of virtual trips on the left side, but there's no Zoom link. Like yours, you have a lot of Zoom links.
Right.
Your homepage, you see a lot of Zoom.
Yeah.
And then for hers, it doesn't have the Zoom link. Can you let her know?
Yeah,
or-
I will send her. I'm going to send her an email right
No,
now.
she have. No, she have.
I don't have it. I can share my screen.
Okay, Sissy, could you share your screen just to show him where to find it?
Okay.
All right, I'll stop my share.
Oh.